In this video, we'll go over the simulation for the exploration of Faraday's law of induction. We'll click on the first tab. Click on the image below to start the simulation. So we'll click on the image. We'll open the Java program to minimize or reduce the size of the D2L instructions so that we can have both the simulation and the instructions on the same page. We'll set up the simulation using these initial instructions. The bar magnet tab is checked. We'll ensure that all checkboxes on the right window are selected except for show field meter, and we'll set the strength to 75% if it's not already set. Step 2, notice you can move the bar magnet around with your cursor. If you hold the left mouse button down, you can also do the same with the magnet. In step 3, place the compass just to the left of the south pole of the magnet and click the flip polarity button on the right hand panel. Question 3, what is the reaction to the compass needle when this happens? The compass needle flips as well as the polarity, since the compass needle is actually a magnet too. When you flip the polarity of the bar magnet, the north pole of the magnet becomes the south pole, causing the compass needle to point its north pole to what has become the south pole of the magnet. Opposite poles attract, like poles repel. Now we'll move the compass to the bottom right corner, and we'll click the flip polarity button again. This time, how does the reaction of the compass differ compared to when it was right next to the magnet? The compass needle changed its direction to align with the reverse polarity of the magnetic field. It did so more slowly, since the strength of the magnetic field and the force experienced by other magnetic objects, like the compass, is weaker at the greater distance from the bar magnet. Let's go on to the Pickup Coil tab. We'll follow these steps to set up the pickup coil simulation. We'll click on the Pickup Coil tab at the top of the simulation window. We'll check the Show Field box if not already checked. We'll set the strength to 75 if not already set to that value. In the Pickup Coil panel, let's click the image of the voltmeter. We'll set the loop's value for 2 and the loop area to 50% if it's not already set that way. And then we'll click the Show Electrons box if it's not already selected. We'll move the bar magnet in step 2. We'll move the bar magnet back and forth through the coil, slowly at first, then more rapidly, to view the effect on the voltmeter. We'll also notice the electron or current flow. Let's be sure to move the magnet all the way through the coils. In question 2, how does the voltmeter reading react when passing the bar magnet through the coil slowly, then more quickly? When the magnet is moved more quickly through the coil, the voltmeter shows a greater deflection, which indicates that more current flow of electrons is being induced in the coil. What happens to the direction of the current flow in the coil? What happens to the direction of the current flow in the coil as the magnet moves one way and then the other? The current flows in one direction in the coil when the magnet is moving one way, and in the other direction when the magnet moves the other way. This can also be seen in the voltage meter, and the indicator needle swings one way and then the other. Let's increase the loop's value to 3 and repeat the instructions from 2 above. Now we're going to move the magnet backwards and forwards. So having done that, what conclusions can we make from the observation of the readings on the voltmeter? The current flow through the coil as measured by the voltmeter increased as another loop was added to the coil. So for the same amount of the magnet's motion, more electric current was produced. Let's go on to the Electromagnetics tab. Let's go on to the Electromagnet tab. And we'll follow these steps to set up the simulation. We'll click the Electromagnet tab at the top. If not If not already selected, we'll click on the DC current source on the right-hand panel and make sure all the checkboxes in the right window except for Show Field Meter are selected. If not already set, slide the battery voltage slider all the way to the right to 10 volts. In step 2, we're going to slide the voltage slider to the left until it reads 0. What happens to the strength of the magnetic field as the voltage approaches a value of 0? The strength of the magnetic field appears to decrease and then disappear completely when the voltage is 0. What happens to the magnetic field as you resume sliding the voltage slider all the way to the left, and why do you think this is so? We'll slide the voltage slider all the way to the left, then back to 0, and we'll put it in its original position and then slide it to the left. So, what happens to the magnetic field as you resume sliding the voltage slider all the way to the left, and why do you think this is so? The magnetic field increases in strength, but it has reverse direction. This is because the induced magnetic field is dependent on the direction of the electron flow, of the current flow, which can be seen to change in the looped coils. Step 3, select the AC current source and note the AC current supply meter. Select the AC current source. The vertical slider controls the amount of voltage. The vertical slider controls the amount of voltage supplied to the coils, while the horizontal slider controls the frequency of the voltage, which is a measure of how quickly the direction of the voltage changes. Slide the vertical slider all the way to the top of its range. What happens to the strength of the magnetic field as the voltage is increased? The magnetic field strength increases as the voltage is increased. In step 4, move the horizontal slider all the way to the right, increasing the frequency of the voltage from the AC power source. How does the change in frequency impact the induced magnetic field? The current changes direction more frequently, so the direction of the induced magnetic field changes more quickly in step with the current direction changes. Let's go on to the Transformer tab. We'll follow these steps to set up the transformer simulation. We'll click on the Transformer tab. If not already selected, we'll select the DC current source on the right. We'll ensure that all checkboxes except for Show Field Meter are selected, and we'll slide the battery voltage to 0 volts. In step 2, move the voltage slider on the battery all the way to the right and observe the effect on the light bulb attached to the second coil on the right. We'll do it once more. We'll start at 0, and we'll slide it to the right. Once more, we'll start at 0, and we'll slide it to the right, and notice the effect on the light bulb. What happens to the light bulb as the voltage is increased? In question 2, what happens to the light bulb as the voltage increases? The bulb glows more brightly in proportion to the speed with which the voltage is increased. Next question, what can you say about the relationship between the lighting of the light bulb and the change in the magnetic field strength? The bulb only lights when the magnetic field is changing. In step 3, we'll select the AC current source and note the AC current supply meter, similar to the last simulation. The vertical slider controls the amount of voltage supplied to the coils, and the horizontal slider controls the frequency of the voltage, which is a measure of how quickly the direction of the voltage changes. We'll slide the vertical slider all the way to the top of its range. What can you tell about the strength of the magnetic field as the voltage rises? As the voltage rises, the strength of the magnetic field increases. And now we'll move the slider all the way to the right. How does the change in frequency impact the speed how does the change in frequency impact the speed with which the bulb turns on and off? And here the bulb will flash more rapidly. And now we'll go on to the Generators tab. Here we'll click on the Generator tab. If not already selected, we'll click on the DC current source on the right-hand panel. Let's go on to the Generators tab. To set up the Generator tab, we'll make sure that we've clicked on the Let's go on to the Generators tab. We'll follow these steps to set up the generator simulation. We'll click on the Generator tab at the top. We'll make sure all checkboxes on the right except for Show Field Meter are selected. There is a slider on the faucet that will allow you to control the amount of water flowing over the water wheel and magnet. The greater the water flow, the faster the water wheel will turn. What happens to the frequency with which the voltage changes as the water flow increases? As the water flow increases, the direction of the current flow changes more rapidly. What happens to the amplitude or strength of the current flow through the looped coils as the water flow increases? The amount of current flowing in the coil increases as the water causes a spinning magnet to spin faster. In step 3, we'll increase the number of loops from 2 to 3. In question 3, what happens to the magnitude of the voltage when the number of loops is increased? We can see that the magnitude of the voltage increases as loops are added. I hope this video on the simulation was helpful, and thanks for watching.